Alright, it's another beautiful day for an outdoor video. Just kidding. I just made the last video a few minutes ago. Still sitting outside because it's gorgeous. So I hope you're enjoying the beautiful weather of this video. Wouldn't it be awesome if you can tell? So, this video is going to be on graphing inequalities. But these are going to be systems of inequalities. So, before we get into the new material, we are going to combine three concepts that we already know. So here's just a quick refresher. To graph an inequality on a coordinate plane, we have our line the same way we would always graph. So we're going to start at a positive 5. And our slope is a positive 3/4. So we're going to go up 3 over 4. And since this says y is less than, remember this is where we use the dashed line. And since it says less, that means we are going to shade below the line. Now remember, there's a trick. If you're graphing in standard form and you have to shade, that's where you need the test point. Okay? So that's one topic that we are going to use. The next one is graphing on a number line. We have x is greater than or equal to -4, and we have x is greater than a -5 because, well, remember, we have to change the direction of the sign. So we have our -5, and we have our -4. This is an AND statement. So we have greater than or equal to a -4. That looks like this. We have greater than a -5. That looks like this. And of course, AND statements must satisfy both. So that's our final answer. And then the last one is just a graphing of a system, which you learned this chapter. We graphed the first one. We have a -1 with a slope of down 3 over 2. And this is what our first graph is going to look like. And then the second one, we can graph using intercepts as long as you're careful. So we have x is 3, and we have y is -6. And we're just going to graph this line like that. And the solution to our system is right here. So we are going to combine all three of those to solve systems of inequalities. Okay? So, graphing systems, here's a little example that we're going to do. And we just combine all three concepts from above. So, the first thing you need to do is graph both of these correctly. So, the first thing we're going to do is graph this piece. So, we have y is greater than 1/3 x minus 4. So, we're going to go to a -4, go up 1 over 3. And maybe want to go up 1 over 3 again. Maybe want to go back 1 over 3 because the more accurate you are, the better your graph is going to turn out. And this is a dashed line. Okay, and since that says y is greater than, we are going to shade above. And of course, you know I like non-lazy graphs. When you shade, make sure you shade it all. Then the next thing that we're going to do is we have to graph this piece. So we have a positive 3 starting point, and we're going to go down 2 over 1, down 2 over 1, down 2 over 1. Hey, look, we found our point of intersection. We will need that. And then we're going to go like this. This is a solid line. And this says y is less than or equal to. So that means we are going to shade below. So here we go. We shade below. And again, remember what I said, no lazy graphs. So I want you to shade even if you know where the area is going to be. Okay, and you can see that the solution to this system of inequalities is in our overlapped area. So sometimes I like to just put a little smiley face over there and say, hey, this is the area that satisfies the solution. So now we're going to name any 3 points that satisfy this system of inequalities. Well, there's an infinite number of points. And I'll tell you right now, it's any point that's in the overlap shaded area. Okay, any point over here, so you can just pick a few. You understand the concept of that. But what I want to get to really quick is the point -5, 3 a solution to the system? So let's go to -5 and 3. That's right here. And yep, that's a solution because it's in the shaded region. How about 1, 1? 1, 1 is a solution because it's on a solid line. And then it says, what about 3, negative 3, right here where they intersect. Now remember, systems of inequalities, it must be true for both. So it is true for the purple line, but it is not true for the blue line because it's dashed and it does not satisfy this inequality, because we would say that 3, negative 3, if we were to substitute that in, we would find out that negative 3 for our y is greater than 1/3 of 3, which we know is 1, minus 4. Is negative 3 greater than negative 3? No, it is not. So this one was yes, because it's in a solid colored region. This one was yes, because it's on a solid line, but this one was no, because he sits on a dashed line. Okay, so anything inside of the shaded region, anything on a solid line is a solution. Anything outside of the shaded region or anything on a dashed line is not a solution. Okay, so what you guys are about to do is practice some of these graphs yourself. So what I am going to do is I'm going to slowly go through some of these equations so you can copy them down on your notes. Or if you've already printed out the note sheet, feel free to just pause the video and go to town. And then what we will do is we will sketch all of these, and I will show you the answers in just a few minutes so we can get through this video in 15 minutes or less. So here's the first two. You have y is less than or equal to 3x, and y is greater than negative x plus 5. And your next one is y is greater than 5/3 x minus 4, and 5x plus 4y is greater than negative 8. So why don't you try those two and pause the video, and then when you press play you will see the answers to these magically appear. Okay, so go ahead, pause the video, try it out. Let's see if we get the same thing. Here we go, it's magic. The first one, you had to shade below your solid blue line, and well, my solid blue line, and your second equation was shading above a dashed line, and there we have our solution right over here. And number 3, we had to shade above both dashed lines, and we get our intersection right there where it all becomes darker. Now I'm using a fancy little highlighter that you guys don't have. If you have a pencil, that is totally fine, as long as I can see where you are shading, and that you make sure that you put a smiley face in your final region, or if you just make sure you color it extra dark so I know without any doubt that you have found the correct region. Okay, so we're going to slide down and do a couple more examples. Here are examples number 4 and 5. As you can see, number 5 has 3 lines that you have to graph before creating your final answer. So go ahead, just like last time, pause the video and try these on your own, and when you press play they will magically appear. Okay, press pause. Okay, here's the magic. Did you get the exact same answers as me this time? Number 4, the region was by parallel lines, and they happen to go in the correct directions. Now, sometimes you have parallel lines and they don't go in the right direction, which means they wouldn't have any overlap whatsoever. But in number 4, the overlap is right in the middle. Number 5, notice how I even did the coordinates for you. Number 5 is actually a preview to what you guys are going to be doing in the near future, called objective functions and linear type of, shall we say, business problems, where we're going to find intersections of multiple lines, and then we're going to shade using inequalities, and we're going to find this, which is going to be known as the bounded region, or this is where we're going to use a lot of these concepts to find maximums and minimums, and yeah, it gets pretty neat. So number 5 is definitely a very important one for you to know. Okay, so we have one more just straight up graphing one with 3 more pieces. I would like you to try this one on your own really quick. Go ahead and pause again. And here you go. Well, there's one more, but it's a word problem. I'm going to save that one for class because this is the most important stuff at this point in time is can you graph systems of inequalities? Okay, so I hope you enjoyed this beautiful weather video, and you know, we will see you soon. This is Longo, and I am out. See you. Bye.